Okay, this video is about enthalpy cycle questions. I'm going to work through a couple of questions with you and give you the prior knowledge that you need to be able to answer these questions. Okay, so first, in order to work out enthalpy cycle questions, you need to understand what the standard enthalpy change of combustion is. So the standard enthalpy change of combustion is when you take 1 mole of a substance, for example decane, 1 mole of a substance, and you completely combust it in oxygen. So it's the enthalpy change for the complete combustion of 1 mole of a substance in oxygen. And complete combustion will give carbon dioxide and water. And your state symbols are important because it says standard enthalpy change. Remember, the standard conditions are 298 Kelvin or 25 degrees and 1 atmosphere. And if you have any solutions, the concentration is 1 mole per decimeter cubed. Okay, so we need to balance this equation. So when you're balancing it, you balance the carbons first. There are 10 carbons, so you're going to put a 10 there for 10 carbons. Then you balance the hydrogens next. There are 22 hydrogens, so therefore you're going to need 11 hydrogens here. And then finally balance the oxygens. So there are 20 oxygens and there's 11 oxygens, so that is 31 oxygens. So you can put 31 over 2, or you can put 15.5. You can write either, it's okay. Okay, so that's the complete combustion of standard enthalpy change of combustion of decane. Here's another example, propan-1-ol. So I'm just going to write this a little bit not as long, so I'm going to put C3 and H7OH. So still propan-1-ol, and propan-1-ol is a liquid, and it's the complete combustion of 1 mole in oxygen, and that's going to give carbon dioxide plus water. Okay, and you've got to remember when you're balancing that you never put a number at the front because it is the combustion of 1 mole. Okay, we've got 3 carbons, so we're going to put 3 carbons there. In total, we have got 8 hydrogens on the left, so we need to put a 4 there to give 8 hydrogens. And counting up the oxygens, so we have got 6 oxygens there, 4 oxygens there, so that's 10 oxygens. Now you've not to forget you've got an oxygen here, so we only need 9 more, so you can either put 9 over 2 or 4.5, you can put either. Okay, so that's the standard enthalpy change of combustion. Okay, then next, in order to be able to do these enthalpy cycle questions, you need to understand what the standard enthalpy change of formation is. And that's the enthalpy change for the formation of 1 mole of a compound from its elements. So we're going to form 1 mole. So can you notice that we're putting this on the right now? We're going to form 1 mole of a compound from its elements in their standard states. And the elements are carbon solid and hydrogen gas. Don't forget your state symbols as well. So standard enthalpy change of formation is for the formation of 1 mole of a compound from its elements. And when we're balancing, we can see we've got 10 carbons, so we've got 10 carbons there, we've got 22 hydrogens, so we're going to need 11 hydrogens there. Here's another example, again, propan-1-ol, so we're going to form 1 mole of propan-1-ol, form 1 mole of propan-1-ol from its elements in their standard states, carbon solid and hydrogen gas. Oops, sorry, pardon me, I've not run out of room. Plus, let me just rub that out and put one bit more room here. So we've got carbon solid plus hydrogen gas plus oxygen gas. So the 3 elements. So we've got 3 carbons, so we're going to put 3 carbons there. We've got 8 hydrogens, so we need 4 hydrogens, and we've got 1 single oxygen, so half oxygen like that. Okay, so that's for the formation of 1 mole of propanol. The next question that you need to know in order to work out enthalpy cycles is Hess's law. So Hess's law states that enthalpy change is independent of the route taken. So remember, the symbol for enthalpy change is delta H. Enthalpy change is independent of the route taken. Independent of the route taken. As long as the initial and final conditions are the same. So independent of the route taken. As long as you start and end at the same points. Okay, so let's try an enthalpy cycle question. So it says the question says calculate the standard enthalpy change of reaction for this reaction. And you've got to note you've been given formation data. So for formation data, then the arrows will go up. I've got another video called Enthalpy Cycles, which you can look at this if you want a little bit more information. And this worksheet can also be downloaded from the website. As well. Okay, so we've got formation. So you can see each of them are formation data. So we've got the formation of calcium carbonate, and we're just going to write the value by the side, okay? The formation of calcium carbonate from its elements in their standard states. So from calcium plus carbon solid plus, can you see how many oxygens that we have? We need 3 O's, so we're going to need 1.5 oxygens like that. So that's the formation of calcium carbonate. And then when we complete the cycle, when we got the formation of calcium oxide, can you see that the calcium and oxygen are already there? Okay, we're just going to put the value next to the arrow, minus 635. And then the formation of carbon dioxide, again, the elements are already there. And the value for carbon dioxide is minus 394. So we need to work out the enthalpy change of this reaction. So we're going to the standard enthalpy change of this reaction. So we are going to apply Hess's law. And Hess's law is enthalpy change is independent of the route taken. So going like that, starting here and ending here, okay, going like that is exactly the same as going down and up. Exactly the same as going down and up, yeah? So it's a bit like the analogy we use is that it's like you at home and you are going to college. You're going to college, but maybe you will go to the shops first before you go to college, yeah? So this is your start, this is your end, and that enthalpy change is the same as starting here and ending at the same point. Like I said, there's another video which explains this in more detail. So we're trying to find the enthalpy change. So the enthalpy change of reaction. Okay, so we're going to go down this red arrow like this red arrow. But the black arrow is going in the wrong direction. So we need to turn the black arrow around, which means we change the sign. So it's going to be 1207. And we're going to go up this black arrow. We're going to go up that arrow. So we'll keep the sign, minus 635. And this black arrow is going in the right direction, so we keep the sign, minus 394, and when you add all of that up, it comes to, I hope you're having a go at this as well, it comes to 178 kilojoules per mole, which is your answer. Yes, I hope you're having a go at this too. Okay, let's try one more question. So another question. So calculate the standard enthalpy change of formation of methane. So this time we've not been given an equation. So we're going to need to write the equation first. So the standard enthalpy change of formation of methane. So that's forming 1 mole of methane from its elements in their standard states, carbon and hydrogen. We just need to balance the equation, and you never put a number in front of the methane because it's forming 1 mole of methane. Okay, so that's what we're trying to find. The data that we've been given is combustion data. Combustion data. So when you combust carbon, the value is -394. Okay, and when you combust carbon, you make carbon dioxide gas. Okay, now when you combust hydrogen, you make water. Slight issue here, just to recognize there's 2 hydrogens. This is for the combustion of 1 hydrogen. So you're going to form 2 waters. That's for the combustion of 1 hydrogen. So we're going to do -286 times 2 because you've got 2 hydrogens. And then when you combust methane, can you see that your items are already there? They're already there, yeah? So when you combust methane, the items are already there, and the value for that is -890. So now we're going to apply Hess's law. This is what we're trying to find. So we're going to start here. We're going to go down the reactants, and we're going to go up the products, yeah? So the standard enthalpy change of formation of methane, we're going to go down the red arrow like this. So we're going to go down these arrows. They're going in the right direction, so we're just going to copy them. -394 and -286 times 2. And can you see that this black arrow, when we're going up, the black arrow is in the wrong direction, so therefore we need to change the sign. So it'll be +890. So when the arrow is going in the other direction, you need to change the sign. And like I said, there's another video which explains this in more detail. These are just practice questions, and your answer, which I hope you're going to have a go at as well, comes to -76 kilojoules per mole. So these are just some practice questions on enthalpy cycles. Thank you.